Yes. Now we will move on to the next result on it. Yes, so this theorem we have we need to prove that is by applying this lemma 4.421 with W is equal to U, then we have this R2KU is orthonormal if and only if we know that modulus of this U cap of theta mod the whole square plus U cap of theta plus pi the whole square will be 2, and if this is the system matrix and taking this first column you take this as x and second column you take this as y, and what is the inner product between x and x, it is equal to, you will get mod U cap of theta whole square plus mod U cap of theta plus pi whole square. Also is some 1 by 2, 1 by root 2 is here, 1 by root 2 and 1 by 2 is here, and 1 by 2 is here, and we will get from first result that this answer is 1 by 2 into 2, that is equal to 1. So norm of this column, first column x, will be equal to 1, that is the first column has norm 1. Similarly, if this is if and only if statement, because if first column has norm 1, we will have this U cap of theta the norm square plus U cap of theta plus pi the whole square will be equal to 2, and this gives what this set R2KU will be orthonormal. So the set R2KU is orthonormal if and only if the first column of A of theta has norm 1 of A of theta is defined here. So for this, for proving this result, we have proved the lemma, first lemma 4.42, and similarly we can prove that if W is equal to V and R2K V is orthonormal if and only if the second column of A theta has norm 1. So for this we have to prove this union is orthonormal set if and only if the system matrix is unitary. Then applying lemma 4.4.22, the elements R2KU are orthogonal to R2KV if and only if the two columns of A of theta are orthogonal for all theta. Please apply this result. Yes, 1 minute. Yes, this one, the second result. This distinct. These are columns of this on unit. Sorry, system matrix, and these are inner product there between the elements of the set B. And so what we have proved? We have proved that this B is an orthonormal set. This B is an orthonormal set if and only if A of theta is unitary. Unitary matrix means its columns and rows will be orthonormal. That is, their individual norm will be 1, and inner product between distinct columns or rows will be equal to 0. So what else we have in this theorem to prove is that we in this theorem we have to prove this is a complete orthonormal set if and only if the system matrix is unitary. What we have proved now, it is orthonormal if and only if A theta is unitary. Until this statement we have proved. One more statement, one more implication we have to prove is that if A theta is unitary, we have to prove that this set B is complete. That else is to be proved. So to complete the proof, we must show that if A of theta is unitary for all theta belongs to 0 pi, then the orthonormal set beta will be complete in L2 of Ez. So this process we have for this result, for this implication, to prove this implication, we have this if unitary of A of theta for all theta belongs to 0 pi implies unitary of A of theta y for theta belongs to R, because it is U cap and V cap of 2 pi periodic. If we prove the result for this small interval, that will be true for all R and conversely. So we now claim V star U of D of Z star V tilde plus U star U of D of Z star U tilde will be equal to 0. This we have seen somewhere else. In perfect reconstruction, we have seen that Z belongs to, for all Z belongs to L2 of Z. Now, take this note that this U of Z, U of D of Z is equal to Z plus Z star by 2. Now we can complete U composition D of z is equal to u of d of z, that will be equal to 1 minute. Apply the definition of u, that will be equal to d of z of n by 2 if n is even and 0 n odd. What is this d of z of n by 2? Is equal to z of n even and 0 n odd. That is equal to, what is this one? Z plus z star by 2 of n. This is z plus z star by 2 of n. So 1 minute. Okay, we will resume. Z star u, then u of d will be equal to d of z will be equal to z plus z star of n by 2. So now we have this note, and now we calculate v star u of d of z star v tilde cap, this one cap, this is equal to z cap, we have to prove. So now we take cap, what will we get? Now this is equal to something star some element cap is equal to first one cap v cap of theta into u of d of z star v tilde cap. What is this u of d of z? We know that u of d of z is equal to z plus z star by 2. So this u of d of z star v tilde, what we can write, this z star v tilde plus z star v tilde star all divided by 2. So taking cap of this one and cap this one, we know what is the result for z star v tilde cap and star cap. We know that it is equal to this one is equal to this half 1 by 2 we have taken here, and this z star v tilde cap can be written as z cap of theta v cap of theta conjugate. Then z star v tilde star cap is written as this. Similarly, for this full element we can write this identity, and grouping these elements as z cap of theta as common, this half is can be taken as this rearranging this one, and u cap of theta and u cap of theta conjugate become u cap of theta whole square. Similarly, v cap of theta, and hence here also. Now we know that what we have to prove, the unitary of a theta implies the completeness of b. So we have assumed the unitary of a theta. This means that the rows and columns of a theta are orthonormal. This lemma 1.105 you refer. So what is this u cap of theta plus v cap of theta? It is the first row. What is the first row of a of theta? It is equal to 1 by root 2 u cap of theta v cap of theta u cap of theta plus pi v cap of theta plus pi. So in this context this each rows are orthonormal. So what is the value of this one? This one will be, the whole value will be equal to 1, and this value equal to 0. So now we will get this expression as z cap of theta into 1 plus z cap of theta plus pi into 0. This will be equal to 0, and this will be equal to z cap of theta. So we have written that this cap plus this cap is equal to z cap of theta. That is, this one cap plus this one cap is equal to z cap of theta. Take Fourier inversion. This cap will be gone and inverted, and we will get this as we will get this equation as true. This equation as true, 4.54 as true. So now what we have left is that this now d of z star v tilde of k, we know that it is z star v tilde of 2k is equal to inner product of this one. Similarly, d of z star u tilde of k is equal to inner product z. But is we have to prove the set B is orthonormal. What is B? Consists of R2k V union R2k U. This U. So if an element Z is taken such that inner product with both R2k V and for R2k u for all k, that if the answer is 0, then we have to prove, for completeness we have to prove this z is equal to 0. So taking that this fact is equal to 0 and this fact is equal to 0, but this fact is equal to d of z star v tilde. So applying here, we will have d of z star v tilde will be equal to 0 from here, and d of z star u tilde will also be equal to 0. That is, we have proved this expression. Here d of z star v tilde will be 0 and this will be 0. Both of these components will be 0, and convoluting with u and convoluting here with v 0 vector, the answer will be, we will get left hand side as 0, that is equal to z, that is z is equal to 0. This proves the orthonormality of the set B. So we have proved the full results from this part, that is this set is complete orthonormal set if and only if their system matrix is unitary. Okay, 1 minute. So now we will resume this 1 minute. Yes, this result also we have proved, theorem 4.46 we have proved now, and this ah, from here we can draw that from theorem 4.46 we, this shows that the orthonormality of B is equivalent to, that is if and only if statement we have proved, this is equal to the unitary of A of theta for all theta. This can be extended to all theta, because if we prove the result for 0 pi, then it is also equal to all theta, because this is periodic with period theta, and this orthonormality of B is equal to, it is a unitary property of A of theta. By the second part, the unitary of A of theta implies the completeness of this set B. B is complete. So now, so okay, now we will move on to the next lemma. Suppose u belongs to L1 of Z, then it also belongs to L2 of Z. Then R2KU is orthonormal in L2 of Z. Define a sequence V from U. Suppose you take U from, and taken that the even number translates of U will be orthonormal, then we can define V, and by V of k is equal to minus 1 raised to k minus 1 U of 1 minus k conjugate. Then these R2k V union R2k U will be complete orthonormal system. By this result, we only need have this U element. We don't need to have this V as a separate element. You can construct V from U, that is V is equal to minus 1 raised to k plus 1 from U. A similar result we have seen in finite case. So U belongs to L1 of Z, then this V belongs to L1 of Z, because summation mode V of k will be equal to summation, if we take mode minus 1 raised to k minus 1 U of 1 minus k, this conjugate will be equal to summation mode of minus 1 raised to k minus 1 will be equal to 1, and this will reduce to 1 minus k conjugate whole, and this k belongs to z, and k belongs to z here, k belongs to z. So what is this one? This is this is equal to k belongs to z. You can uh, 1 minus k, you can change the index to some m, and this you can write a summation mode u of m. This m belongs to z. Since u belongs to L1, we can say that this quantity is finite, though this v is also finite, so this v belongs to L1 also. So it is clear that v belongs to L1 also. By lemma 4.421, the if this set is orthonormal, we can write this one for all theta. And now you calculate v cap of theta. What is the expansion for v cap of theta? Summation k belongs to z, v of this, what do we have written? V of k. This v of k e raised to I k theta. That is the definition for cap, Fourier transform. That is, what is v of k? V of k is minus 1 raised to k minus 1 u of 1 minus k conjugate. E raised to I k theta is also there. But this can be written as minus 1 raised to if we change the index 1 minus k2 is equal to some j, then we will get minus 1 raised to k minus 1, k minus j we have written here, u of 1 minus k, u of j, e raised to, for k we will write here from here 1 minus j is equal to k. So 1 minus j is also written, conjugate is there. So now minus 1 raised to minus j, minus 1 can be written as e raised to I pi raised to minus j, e raised to minus I pi j. We now obtain v cap of theta, this one, thus summation j belongs to z. Minus 1 raised to minus j we have written like this, e raised to minus I pi j, e raised to, here minus I pi j will be here. I will write this one, summation this e raised to I theta into u of j, e raised to I j into theta, 1 minute, theta plus pi minus, here it is also minus, the whole sorry, this whole conjugate. This can be written as minus 1 raised to minus j, u raised to minus I pi j, this theta plus pi here, e raised to minus I pi j is here, and this u of j is here, e raised to I into j theta, e raised to I j, sorry, minus I j theta. This I into 1 minus j you have written, sorry, this yes, minus I j theta will be here. So sorry, plus I j theta, sorry, plus I j theta will be here. So taking the whole conjugate, we can this is inside summation, so we can we have the result that if it is summation z of n whole conjugate will be equal to summation z of n the whole conjugate, because this conjugation can be taken outside of infinite sum, n belongs to z, n belongs to z. This is a result you can refer Google, or if you can also write this if z of summation minus n to n, z of n goes to summation z of n is equal to some z. Now this we have this result. Now you try for the convergence of minus n to n, z of n conjugate. You try for this series, how it converges, and you prove that the limit will be equal to summation z of n or conjugate. You can prove by taking epsilon n, this one, or else I will give. If you get, if you don't get, you approach me. You can Google also, you can get the proof of this result. Okay, anything. Okay, anyway, v cap of theta is equal to the this one, the conjugate can be taken outside. So what is this one, e raised to minus I theta can be taken outside of the summation, so here it will be e raised to minus I theta, a conjugation is there, so together with the conjugation we will get e raised to I theta. So what is left inside the summation, summation j belongs to z, u of j into e raised to I j of theta plus pi the whole conjugate. What is the answer for this summation? It is u cap of, definition of u cap of theta plus pi the whole conjugate. So we will get v cap of theta like this. What is v cap of theta plus pi from this result? Put theta plus pi instead of pi here. We will get left hand side this, right hand side e raised to I into theta plus pi into u cap of theta plus pi plus pi, pi plus pi, 2 pi will be here, and the conjugate, what is u cap if periodic with 2 pi, so we can this write this one as u cap of theta conjugate, that is written here, and e raised to minus I theta, e raised to e raised to this gone as e raised to I theta into e raised to I pi. What is e raised to I pi? It is minus 1. You can take. So we will get this one, and we get v cap and u cap from here, and u cap also we know This is the rest part is solved in solution manual. You can write here this similar to the proof that we have earlier in the first module also. In the there is a similar result that we have taken um, using a of theta, the rows of a of theta, and in solution manual the answer is here. You can refer solution manual. So we have what we have proved is that if we know this u, if we take u such that r2k u is orthonormal, then construct u v from u, and this set will be orthonormal system, that is the first stage wavelet system. Now we produce uh, a first stage wavelet system r2k v union r2k u of l2 of z, then yields a first stage wavelet basis for L2 of Zn finite case. So a first stage wavelet system in infinite case will yields a first stage wavelet basis for finite case. This process is known as periodization, and there's a lemma for periodization. That is periodized wavelets for L2 of Zn finite. Here it is finite, and uh, we have arrived here from infinite case. Let m belongs to n, and 2m be this n. Suppose u and v belongs to the infinite space L1 of z, such that r2k b union r2k u is a first stage wavelet basis. The lemma, just before lemma we you um, approach this first wavelet system for L2 of Z, define un and vn that are elements of this finite space L2 of Z, and by un of n, nth index will be summation k belongs to z u of n plus kn, and vn of n will be summation v of n plus k. Um, these sums converge because we have taken u and v from L1 of z. From L1 of z we know that u of uh, mod u of n is convergent. This is absolute convergence. Absolute convergence means convergence. So this summation is also convergent. So this convergence can be, this is a finite value. We can uh, take the finite value to un of n. Similarly, in this case also, both these series converges. Now, then we have to prove that R2K V union R2KU will be a first stage wavelet basis for L2 of ZN. Now, in the finite case un, we will take the DFT. What is the DFT? Un cap of m will be equal to, apply the definition for discrete Fourier transform of finite case, it will be summation discrete 0 to n minus 1 un of n e raised to minus 2 pi nm by n. This is equal to summation, this summation n 0 to n minus 1 is written here. What is un of n? Un of n is equal to summation k belongs to z u of n plus kn e raised to minus 2 pi I nm by n. And this summation can be written as u of k plus n by n e raised to minus 2 pi n plus kn by m by n. This can be written how? This e raised to minus 2 pi I small n m by n, that is written here. The rest is e raised to minus 2 pi I k n by n. This capital N goes. What is e raised to minus 2 pi I k? You compute the value as 1. So we can write this as this in this form. Put the index transformation to L is equal to n plus k n. We can write this summation. What is n is equal to 0 to n minus 1. So for n is equal to 0, first you initially take. What will we get? Summation k belongs to z u of this 0 plus kn, k times n, this k belongs to z, and e raised to minus 2 pi I kn m by n. That is the kth multiple components will be appear here in this u. So what if n is equal to 1 here? If n is equal to 1, 1 plus kn times multiple times will appear here. Um, Ah, nth multiple from the index 1, 1 plus k, that is 1 plus, if n is equal to 10, then we will get u of 1 and u of 11, u of 21, etc. like that. So for n is equal to 1, you will get from like that times. If n is equal to 2, you will get u of 2, u of 2, u of 12, u of 22, u of 33. So if we take 0, n is equal to small n is equal to 0 to n minus 1, you will get all the u values. Summation k belongs to z, u of k. All the k values will appear here. So this summation, when while expanding, we will get u summation um, Ah, and changing the index n plus kn to L, we will get this only one summation arrives here. Summation L belongs to z, u of L e raised to minus 2 pi I L m by n. This is replaced by L, and this, what is this result? This result is u cap of the index minus 2 pi m by n. U cap of m is defined minus 2 pi I n m by n. So this minus 2 pi I m by n u cap is written here. So we have got u cap of n of m will be equal to u cap of this term, and now up now we calculate u cap of capital N of m plus m. You replace this m by m plus m, then you will get u cap of this. You replace here m also, minus 2 pi into m plus m by n. Splitting these terms, two terms, I will get minus 2 pi m by n, that is minus 2 pi m by n, minus 2 pi capital M by n. What is this? It becomes 2 into m is equal to n. So minus pi will remains here. Minus pi is written. What is this one? U cap of minus 2 pi m by n. Ah, this, since u cap is 2 pi periodic, then apply plus 2 pi. Plus 2 pi and minus pi here, we will get plus pi. So u cap of n of m plus m is equal to u cap of this one. This so applying the same identities with u replaced by v, so we'll get v cap n of m will be equal to v cap of minus 2 pi m by n, and similarly. Now the we know that this is a this R2K V union R2K U is a first stage wavelet system. So there, what will we get there? Their system matrix will be unitary. So for each theta, we will have the system matrix A of theta for U and V will be unitary. If theta is equal to minus 2 pi n by n, also this A of theta will be unitary. So now this now we consider the system matrix A of n of un and vn. So if theta is equal to minus 2 pi n by n, we will get all the n indices. Uh, so from 0, n is equal to 0, 1, 2, 3, etc. up to n minus 1 by this relation. For this n's also, a of n will be, the system matrix A of n will be unitary. Since A of theta is unitary for all theta, then A of n will be unitary for all n is equal to 0, 1, 2, 3, etc. up to n minus 1, because these indices are contained in here also. Just take n, capital N is equal to uh, n is equal to 0. What will you get? If for all theta this is true, so you take this theta 0. What is this 0? 0 we will get for all theta, this is true. For theta is equal to 0 also, this is true. So theta will be equal to 0, then minus 2 pi n by n. This implies what? Small n is equal to 0. So for small n is equal to 0 is included, you can take this as you can take this uh, theta's minus 2 pi by n, then we will get small n is equal to 1. So likewise for n is equal to 0, 1, 2, 3, etc. up to n minus 1, the A of n system matrix is unitary. In the discrete case, this unitary implies what? R2k Vn and R2k Un from k is equal to 0 to m minus 1 will be a first stage wavelet basis for L2 of AZ. So what we have proved is that if we have u and v such that R2k v is union R2k u is a first stage wavelet for infinite system L2 of Z, we can construct u and vn for discrete space L2 of Zn such that it will be a first stage wavelet basis for L2 of Zn for finite case also. So what are they? What now we have to prove the corollary also. Suppose U and V belongs to L1 of Z such that R2K V union R2K U is a first stage wavelet system for L2 of Ez, not basis. It is a system. Suppose now U of n is defined, and U suppose now and suppose u of n and v of n is equal to 0 for n less than 0, that is minus 1, minus 2, etc. to the left up to minus infinity, and n greater than n minus 1, that is n plus 1, etc. up to plus infinity. Only finite number of times, only for finite number of times we have this u of n and v of n as uh, some finite non-zero value. For all other infinite indices we have the value of this u and v as zeros. Such u and v are taken here. So and define we define un of n is equal to, and we define un and vn belongs to L2 of Zn. So we can define because these finite terms are non-zero, and this un of n is equal to u of n and vn of n is equal to v of n. So by this condition, we can write un of n is equal to summation k belongs to z u of n plus k n. In this format, we can write this this vector. This vector can be written as this form. Why? Because here u capital N of n is equal to u of n. U of n will be here from 0. Some index will be from n minus 1. Some index. So look at this summation only the index that comes inside 0 1 2 3 etc up to n minus 1 will be non-zero here. All other summation, all other terms in this series will be 0 because infinite number of terms are 0. So this summation, so this can be written as this form. Similarly vn can be written as summation k belongs to z v of n plus kn also. So what we have reached, we have reached this result in the format, this format. All these cases are arriving here. So what we can assert that R2k v n union R2k u n is a first stage wavelet basis for finite space. So what will we get? We'll get R2k Vn union R2k Un will be first stage wavelet basis for finite space. So this is the proof that we have written. The only case is here that this statement and this statement can be written as summation form and apply the earlier this lemma 4.48. And here also some items are here. Dobach's wavelets. You will study this after that. Okay. This completes this section 4.5. Okay, thank you.